everybody. In this video what I'm going to talk about is how raw counts can be a little bit misleading if we just take them at face value. Now, right now, as of March 2020, something that's pretty topical around the world is COVID-19, this pandemic that seems to be sweeping the globe. But what I want to talk about is use that as a bit of context in terms of illustrating how counts can be a little bit misleading. So at the moment, we often get reported how many cases there are in different countries, and the number that's being reported, so the number of cases, cases being reported regularly in the newspaper is a combination of two things. So it's the real number of cases, which I'll just call C, times some sort of reporting rate, which I'll call R. So that's sort of a combination of whether the cases are diagnosed as COVID, and then also whether that number is reported or not. Now, what we're really interested in oftentimes is that true number of cases, C. And unless that sort of reporting rate is close to 1, then we're going to be underestimating what the true number of cases are. Furthermore, that value, that reporting rate, will probably vary from place to place. Different countries with different sort of levels of health systems probably have different abilities to diagnose and report COVID cases. We also have a situation where it probably varies in time. So early on, at the early stage of infection, that reporting rate may be a bit lower than later on once the disease has progressed more through the population. So the viruses do progress more through the population. So we were starting to look at and comparing the number of cases in different times or different places. That's not necessarily just a reflection of a change in the true number of cases, but also is a reflection of the true number, also the true rate of reporting as well. Now, sort of linked to this, and oftentimes we get talked about the sort of mortality rate of COVID, and so the number of reported deaths. So sorry, that should be the number of reported cases, because that's the number that we get told about all the time. Similarly, the number of reported deaths due to COVID is the true number of deaths times sort of the death reporting rate, which is probably pretty high. I'll call it Q. Okay, so Q is probably fairly close to 1 in most sort of modern health systems. If a person actually dies of COVID, then it's probably actually successfully diagnosed and recognised as that. Now the thing is though, when we talk about the mortality rate, we're taking the ratio of these values. So sort of the apparent mortality rate is the ratio of these two values. So that's going to be the true number of deaths times that death reporting rate divided by the true number of cases times that reporting rate. And if I rearrange that slightly, it's the number of deaths divided by the number of cases times the ratio of our two reporting rates. Now the key thing here is that this is the true mortality rate of COVID. It's the true number of deaths divided by the true number of cases. And that's the thing we're really interested in if we're trying to identify that mortality rate. But that's multiplied by the ratio of these reporting rates. And that number there, Q, let's presume it's pretty close to 1. Don't know it is, but let's presume it is. But if R is a lot smaller, then what that means is that this ratio here is going to be sort of too big. It's going to be bigger than 1. This value here will be bigger than 1, which means we're going to sort of overestimate what that true mortality rate is. And people have been talking about this in the media, recognising that the sort of raw mortality rate that we get out about COVID, sort of ranging around 3%, is probably actually too large because we underestimate the true number of cases. And so unless this ratio here is exactly 1, which will happen when either both values are 1 or both values are exactly the same, then we're going to get a biased estimate of that mortality rate. Now, I'm just using COVID here as kind of the application. It's exactly the same situation whenever we have some reported counts being given to us. So things like crime statistics, we often talk about the amount of reported crime and how that might be changing over time. We have a similar situation. There's the true number of sort of crimes times that reporting rate. When we see a change in the reported crime rate, that may be a combination of both the true crime rate but also the rate at which crimes are reported as well. Also, in the case of ecology, we often use counts of individuals, counts of animals, to sort of look at how the population might be changing over time. It's the exact same sort of argument. If we're comparing sort of the raw counts of how many animals we saw in an area in 2 different times, for example, then that's only going to give us an unbiased estimate of the true number of animals there if sort of the detection probabilities are exactly the same at the 2 times or places. So there you have it, a little bit of a quick talk about how our raw counts can be misleading if we're not careful, and just to illustrate how it can be an issue. So I hope you found that useful. Till next time, see you later. Bye.